1,500 words. So not a very big report. It will be 10 pages maximum, nothing more than 10 pages. In that report, I want to see the following: that you demonstrate you understand the theory behind the approaches. So that means I need to see what is the baseline or what is the underlying theory that you've used. Why are you using this? For what end? You explain the method and describe the steps taken to validate your results. So, for example, you've tested a network. How do you know that your results are accurate? So, validation means different things. A, validation of data, that the network generalizes well, that you've tested the same network multiple times so that you can get its average performance. So, the results that you're showing are valid. And results should be presented clearly and with numerical critical analysis. So the task, as I will explain in a bit, is basically building multiple networks using two different approaches, using artificial neural fuzzy inference systems, which we studied last week, and using multi-layer perceptron. And then you want to show me the results. So the way you demonstrate results is up to you. You can show figures, you can show tabular data, you can show bar charts, but they have to be clear and they have to be explained and they have to be critical. So there's no point of just putting a bunch of pictures saying that these are the results and that's it. It's more about analysis and explanation of your findings rather than just placing findings from it. Now, there should be a discussion of results and conclusion, and that is the very most important part of your success. Now, let's look at the assignment. The assignment has a total of 5 tasks that all needs to be carried uh, together. So, completing one task only or two only will not guarantee you pass mark. You need to have to look at all different 5 tasks. So, task 1, you'll be given a code in MATLAB, a pre-existing code for a 2-arm inverse kinematics planner, which I'll explain in a moment. And your task 1 would be A, to look at the 2 different networks, which you already have, but you'll have to do some experimentation on. So you need to change some parameters, do a little bit changes to the code, just to see that you get the best performance of the network. So to get the best performance, you need to do some testing and trial and error and experimentation. And then you have to learn the performance, monitor it. So you build a network. You already have the base for it. You just need to manipulate a few things, especially the training and validation data. You have to learn the performance and monitor it using appropriate validation to show evidence. So you need to make sure that you show in your report, because in the report I will not be marking your MATLAB file. And it will not be a single MATLAB file. You'll test the network multiple times, tens of times. And so what I want to see is these tests that you've done. You're writing about them, you're summarizing your critical analysis of your findings. And then after training, further testing should be used to compare solutions. So let's say I built 3 different networks. One that has, for example, size of X number of neurons, and the other has X2 number of neurons. So which network performed better, and so on. So you need to do some analysis and comparison until you achieve the best performance based on your trials. And you need to tell me that I've tested with these different parameters and with these different parameters, and the performance was that, and so on, so on, so on. So you need to explain your performance in the report. So that is task 1, which are 3 separate tasks. First, build the NFS networks, then monitor the learning performance, and then after that, do multiple testings to perform for performance to check which one is better. Then repeat this task. So the first part will be using ANFS network. Task 2 would be to repeat task 1, but this time we're using a multi-layer perceptron network. So different type of algorithm, a different type of neural network. Same problem, different network. So you'll have to do the exact same things. You have to test with different parameters for the network. You have to check which one had the most significant effect, which one performed better, and so on. So now we have 2 approaches, one with artificial neural fuzzy inference system, one with multi-layer perceptron. Then tasks 3 will be the comparison of these 2. Getting multi-layer perceptron to artificial neural fuzzy inference system. Then task 4, you are going to repeat tasks 1 to 3, so 1, 2, 3, but this time with an extended problem. So the problem at first will be 2 arms. In the 4th task, would be 3 arms. What are the changes I will introduce? So it will be a repetition of tasks 1, 2, and 3, but this time with a bit more complex implementation. So this would be task 4. Task 5, which is the final task, is a research task. So you have to go online, you have to look into publications, research, journal, conference papers of based on this, uh, why is the performance not so great? Because we're expecting that the performance is not very accurate, and suggest any other approaches that may be used to achieve higher accuracy. So when we actually extend the work to 3 arms, you'll see that the performance is not as good as 2 arms, and in general it's good. So you need to go and do some research into why it was bad and how it can be improved. Here you don't have to implement your findings, you don't have to test them, you just have to search and write about them. So task 5 does not require you to do any modeling or simulation, just analysis and just the research task. So these are the 5 tasks. Now here is the marking criteria. So if you notice, marks, once I go through them, you'll notice most of them are about discussion, about analysis, about critical assessment in a way. So for example, explaining methods used, that is 20%. And explain everything, task 1 to 4. If you the way you choose to show your results, that will be another 20% mark. So results display, are they just figures floating, or they are figures with proper labels, proper data, clearly understandable figures? Then the critical assessment and analysis of results, the way you analyze your results, the way you compare your results, the way you judge your results in writing, of course. And then the research task, which is only review, that will be another 20%. Your discussions and conclusion will be 10%, your final conclusion, and your references, because you will use references, especially when you're in, at least in task 5, you have to use some references. The way you put your references, that will be another 10 marks, and I think reference marks are easy marks. You just need to properly use Harvard style, include the reference list, reference within text, and follow the structures. So this is the general description of the assignment. Now, I would like you all, because most of you are working students, to be aware of our late submission policy, which has been changed recently. So as of now, the submission deadline is on 18th of December. But you are given 5 days grace period, which means if you are late after the 18th, you have 5 more days to submit within those 5 days without having to apply any form. But the trick is, now that is generous, 5 days without having to fill any form, you can submit. But after those 5 days, no submissions will be accepted. So there's no exceptions, there's no emergency situations. If you have any situations, then you'll have to fill up another form, which means that you'll submit later on the summer period. If you cannot submit within that time, the submission will only be in the summer. So that is the new late submission policy. So please be aware of it, use it to your advantage, but give yourself, plan ahead, give yourself ample time to submit within the deadline. Now, let's go to the 2-hour planner. So I explained this briefly last week, but I'll explain it again today just to give you a clear indication of what is it that is expected from you. So, are we familiar with inverse kinematics? Are we familiar with robotic arm? Okay. So, let me just use it. Because this is recorded, I'll not use the board. Write it down. So what you have, assume that we have a robotic arm that has 2 extensions, or that has 2 legs. So let's assume that, let's say you have a base, and within that base there is a robotic arm installed. So this arm is connected to the base by a joint, so it can move freely through that joint. And this arm has length L1, from this point to this point, okay? And it creates an angle of theta 1 between the joint and between the arm and the base, okay? Then this arm is connected to another one through a different joint, and it has a length here, let's say it has a length L2, and it creates an angle theta 2 with the extension of the first arm. Yeah. So usually in applications, the second arm is actually connected to a gripper or a grapper or some sort of an installment, but we're only concerned with the objects. So one of the applications, can you tell me of an application of a robotic arm? Such an arm, where would it be applied? In factories, right? So it will be used to grab something or place something or take something from one point to another point and so on, right? So it will be there. So usually the task required is you want to control the angles, theta 1 and theta 2, because you know the location. The xy coordinates are known. So let's say that when it comes to degrees of freedom, it has 2 degrees of freedom. Meaning it can move in the x plane up and down and y plane only. So it doesn't have a 3-dimensional, think of it as a 2-dimensional set, not a 3-dimensional set. So we have xy coordinates at which this end point is located, right? So now if I assume, these are given information, so you are given the length L1 to be x meters, the length of L2 to be x2 meters. And you're told that theta 1 can be any value between 0 and 90 degrees. And that theta 2 can be any value between, let's say, 0 and 180. So now you can predict the workspace, all the areas or possible locations that they can have, which would be somewhere from here all the way to just different shape. So for example, the least location for theta 1 is to be 0, which is here, right? And the maximum location for L1 is to be 90 degrees, which is here. Yes? And it can exist in anywhere in between these two. Then, for the second arm, it starts with 0 degrees with the extension, which means here, all the way to 180 degrees with the extension, which means all the way reversed. So then here, and all the way, can be here, all the way up to here, right? Back to the location. So I can say that the working field is all this, right? Could be anywhere in this there. So this is the first thing we need to know about this. Now, the second thing we want to do is we want to build an artificial neural fuzzy inference system to control this arm. Meaning, if it was fed to the xy coordinates, it can dictate how much theta 1 and theta 2 should be. Or in other words, think that these joints are controlled by motors, right? So you want to, the actual ultimate value that you want is how much you are going to change or how much current will pass through the motor for how long of time, right? Which means you want to know what theta 1 and theta 2 is. So your system's input will be xy coordinates. Your system's output, your neural network's output, should be theta 1 and theta 2. Right. So, in general, what is the first step we have to do when we want to build or design a neural network? Whether it's a neural network, nuclear perceptron, or artificial neural fuzzy inference system. What is the first step? So we design the system. We have to use some training data to train the system. We have to validate the system, and then we can use it, right? So step one is we need data to train the system. We don't have that, right? So one of the simplest approaches is to use Pythagorean theorem and trigonometry to find the relationship between theta 1, theta 2, x and y. Here. So if I plot the XY plane. And let's say that this is L1 and this is L2. This would be the X coordinate, right? And this would be the Y coordinate of this point, X, Y, right? Now, if you make a right angle triangle here, can we tell how much this value is? We know that the angle here is basically theta 1, right? So the length from 0 to this point is equal to L1 cosine theta 1. That's from Pythagorean theorem, right? And the same thing applies here, that this length is L1 sine theta 1, right? Now let's look at this triangle. And we can find the distance here from here to here. We know that if this is the extension of L1, this angle is theta 2, right? And since this line over here parallel this axis, this means what is this angle here? So this angle is theta 1. This angle would also be theta 1, right? Because it's theta. So this would be theta 1, which means that the entire angle of this right angle triangle is theta 1 plus theta 2, right? This entire angle is theta 1 plus theta 2, right? So therefore, again, we can say that the area here is L2 cosine, the length here, theta 1 plus theta 2, right? And the length here is L2 sine theta 1 plus theta 2. Here. So if I want to find this x coordinate here of this point, how much would it be? It would be this value plus this value, right? And the y coordinate will be the same thing, the first y dimension plus the second y coordinate, right? So knowing this, knowing that x is equal to L1 cosine theta 1 plus L2 cosine theta 1 plus theta 2, and that y is equal to L1 sine theta 1 plus L2 sine theta 1 plus theta 2, we can actually create training data, right? By saying, let's create theta 1 and theta 2 values and their corresponding x1 and x2 values. So we can say that theta 1, theta 2, and then x and y. And then we can say that, well, I can look at theta 1 values from 0 to 90 with a step of 1. So it will be 0 degrees, 1 degree, 2 degrees, all the way to 90 degrees, right? And then I can do the same thing for theta 2, 0, 1, 2, all the way to 180. And then I can use these two formulas to calculate what x and y equals to. So now I created a table of data of theta 1, theta 2, x1, and y. So now I have training data. So the next step would be, you've learned in the practical how to build an ANFIS network. You've also learned how to build an MLP network. So can we build them using this data? We can, right? Now there is one thing, however, we need to pay attention to. Now in ANFIS network, artificial neural fuzzy-based networks, what is the only thing we notice about the output of the network? How many outputs there are per network? So if you remember, let's